morning all of you. Today we are going to see about the concept of formal definition of a DFA. So before that, what is the meaning of DFA? This is nothing but the deterministic finite automata. So in this deterministic finite automata, this is the basic structure of the deterministic finite automata. So it consists of a 5-tuple notation basically. So these 5 tuples are the first one Q. The Q is nothing but the number of finite set of states. And second one is sigma. The sigma is called as a finite input alphabet. Okay. And the next one is Q0. Q0 is represented as a initial state of the transition diagram. And capital F is representing it is a final state of a transition state. Okay. And the next one is delta. So the delta is a transition function. So these 5 tuples are refining the concept of your deterministic finite automata. So this Q consists of a number of set of states which is started from the Q0 to Qn. Okay, so it consists of a more number of states based on the input alphabet. And the next one is sigma. This sigma is called as a finite set of input alphabet. That input alphabet may be a number of digits, maybe 0 to 9, or maybe input alphabet A to Z. Okay, and the next one, the Q0 is Q0 is starting state. Okay, so initial state or starting state, and this final state we should consider one point in this final state. In a transition diagram, if any of the state is encircled with two circles, it is called as a finite state. Okay, so the final state double circle, if any of the state is marked as a double circle, that state is considered to be a final state of a transition diagram. And delta, this is one simple transition function. This transition function is consist of a one state which is initial state and with one input symbol. So Q on S is producing the output of Q dash, which is the meaning of this input symbol is reading with one state and producing as a one output state. So this is one basic syntax and structure of a DFA transition concept. Okay, and next, this is one basic example of a DFA transition diagram. So here consider two important points. The first one is transition diagram, that means DFA transition diagram, and this is called as a DFA transition table. Okay, so if any one of the input is given, you can construct another one. So suppose if the transition table is given, you can construct easily this transition diagram. If the transition diagram is given, and you can construct the transition table. Okay, and also from the transition diagram you can find out these values also. Okay, so Q, as per our concept, the Q is called as a how many states available in a DFA transition diagram. Yes, this is our example. So from this example you can consider how many states occurred in this transition diagram. So I think two transition states available. So Q0 and Q1 are the number of states available in this transition diagram. So the capital Q consists of a Q0 and Q1. Okay, and next, this sigma s represents how many input symbols are available in this given transition diagrams. Yes, as per our seeing here, we have a two input symbols, 0 and 1. Okay, but the transitions may be more than one, but the input symbols are 0 and 1. So you can bring it here, the sigma equal to 0 and 1. And next, starting state is Q0. Yes, this is starting state. This arrow mark is represents here starting state of a transition diagram. So the Q0 is a initial state or starting state. Okay, and next one, capital F is called as a final state. As per our definition, capital F is defined as an accepting state or final state. Okay, so in this transition diagram we have a final state, and the final state you should be marked with a double circle. So Q0 is again acting as a final state. Okay. Also, this is initial state in this given example. Okay. But it is not compulsory to give initial state. Also, all the diagrams must be a final state. Okay. So this is not a final one. So you can have a Q0 as initial state and F may be a final state. Okay. And the next one is this is transition table. Okay. So now all of you listen that transition diagram and check the state first Q0. Okay. So in a Q0, check with how many input symbols are traveling from the Q0. Okay. So in that Q0, there are two input symbols are traveling from the Q0. One is 0 and another one is 1. Okay. So now Q0 on 0. This Q0 on 0 where this input symbol is reaching. Okay. So Q0 started from the Q0 and the input symbol 0 is traveling, and check with the transition diagram where that transition input symbol is reaching. Yes, Q0 on 0, it is reached with the state Q1. So I can put here the value of Q1 or the state of Q1. Okay. And the same Q0 on 1. Check with Q0 on 1 in your transition diagram. The Q0 on 1, the input is traveling from Q0 to and again reaching with Q0 itself. So I can mark it as a Q0. Q0 on 1 is again reaching with Q0. So this is called as a self transition. The input symbol is traveling the same state itself. So we can call it as a self transition. And the next state is Q1. Consider again the same concept of Q1 state and check with in a transition diagram the Q1 state how many input symbols are traveling from the Q1 state. In a Q1 state, there are two input symbols again traveling. The one is 0 and another one is 1. So Q1 on 0. Check with the diagram. Q1 on 0. It is reaching with Q0. So my output is here Q0. And the next one Q1 on 1. Again it's a self loop. So Q1 on 1. Again it's reaching with the same state. So my output is here Q1. Okay. So this is for the simple transition diagram and simple transition table of deterministic finite automata. And also you have a one more clue here. How to check this diagram is a DFA transition diagram. Yes, there is a one condition in the same input symbol in a all DFA transition diagram. The same input symbol cannot be traveled more than once in a particular state. Okay, so which is in the meaning of the Q0 on 0 is moving only once in a Q0 state, but it is not moving somewhere of the transition diagram. So if there is a only one transition of one input symbol or same input symbol, then the diagram is easily analyzed with the deterministic finite automata. Thank you, students. So next class we will see about the non-deterministic finite automata concept. Thank you.